Hi, welcome to Dr. Vanderveen's AP Chemistry podcast. Today we are talking about significant figures. There are two main objectives for this podcast. The first thing we want to do is make sure that you're comfortable with the rules for recognizing the number of significant figures in a particular measurement. And the other thing we want to do is make sure that you're also very comfortable keeping track of the number of significant figures that you should end up with after as a result of a calculation. There are a number of rules we'll be going through. The first rule is the foundation for all of them, and rule number 1 says all non-zero digits are significant. Some simple examples. All right. If we go to the number 12, it has two significant figures. The number 342 has three significant figures. The number 2,223 has four significant figures, non-zero digits, unambiguous. The final example here has 1, 2, 3, 4, 5, 6, 7 significant figures. Our next rule deals with a situation that are sometimes referred to as captive zeros. And captive zeros are always significant. Well, what we mean here by captive zeros, we'll show you in the examples, are zeros that are sandwiched in between non-zero digits. So the number 101, the classic example of captive zeros, has three significant figures. And the number 2008 has four significant figures. Sorry about that. Our next rule deals with a situation of zeros called leading zeros. And in leading zeros, what we mean are zeros at the left-hand side of a number. And these leading zeros are never significant. All right, so we've got some examples in here. All right, so if we look at the number 0.0012, all right, this has two significant figures in it. The reason we say this is we have some leading zeros here. It's at the left-hand side of the number. They aren't significant. If we look at our second example, we also have all these leading zeros. Now we also have a captive zero. The leading zeros don't count, but the captive zeros do. And so this value has three sig figs. All right. If we go on to rule 4, it's a little bit more complicated of a rule. We're dealing here with what we call trailing zeros. All right. And they are not generally significant unless you have a decimal present. Let's go on and look at some examples just to make sure you're clear about this. If you look at the number 1,200, all right, we've got some non-zero digits. We've got these trailing zeros at the right-hand side of the number, but you'll notice there's no decimal point written. And most chemists try to be quite clear about this. Because there's no decimal point, there are two sig figs in this answer, in this value. If we go on to 120.0, however, you'll notice we now do have that very important decimal. And so this answer, or this value, has four sig figs. If we go down to our final example, we've got some leading zeros. They don't count. We've got a trailing zero, but we also have a decimal that I inadvertently erased. So in this example, we also have four sig figs. All right, our final rule deals with scientific notation. Actually, this rule is nice and unambiguous. In scientific notation, all the digits in the coefficient part of the number, in other words, everything written before that times 10, are considered to be significant numbers, significant digits. Some examples here. The first example is a number that should be familiar to you. All right, we have three values here. We've got a captive 0, but that's three digits before the x, and so we have three sig figs in this number. Now if we go down and look at our second example, we've got those trailing zeros. But we don't even need to worry about that because they're all part of the coefficient, and therefore they're all significant. We don't have any leading zeros in scientific notation, so it's nice and unambiguous, and here we also have three sig figs. Now, the other thing we need to do is we need to be able to keep track of scientific or significant figures in our calculations. That's very important. And the main idea here is that you can't gain or lose precision just because you did a calculation. Or, in other words, your calculated answer can't be any more precise or less precise, for that matter, than the least precise value involved. And this is because everything here is coming from measurements. Sometimes students really get bothered by these rules, but you do need to be able to apply them. So one thing you need to keep in mind is the type of operation does matter. And so if you are adding or subtracting, you have one set of rules to follow. In this case, when you're adding or subtracting, your answer is going to be rounded based on decimal places. Whichever value had the fewest decimal places will determine how many decimal places are in your answer, and therefore the number of sig figs. So let's look at a simple example of this. All right. If you need to do the sum of 3.43 meters plus 0.0134 meters, now both of these values have 3 sig figs in them. All right. So that's not really what's going to help us, though. This answer, or this value, excuse me, has 2 decimal places. And this one goes out to 4 decimal places. So when we do this, we have to basically stop our answer here. All right. So when we go to record our final answer, we end up with 3.44 meters. You do, of course, have to include those units. But this is the answer that you would record for full credit here. When you're multiplying or dividing, all right, you have to follow a slightly different set of rules. Same objective, trying to make sure you keep track of your precision. But you want to do this when you're multiplying or dividing in terms of whichever value in the calculation had the fewest significant figures. It's a slightly different way it's applied. All right. So if you have to do this calculation, you have to do 3.4723 meters times 0.26 meters. All right. On your calculator, you get a number of decimals. But what you have to keep in mind here is that although this number has 5 sig figs, this answer only has 2. And so her answer can only have 2 sig figs. And so when we record this answer, we need to record it as 0.90 meters squared. Right, so you do need to make sure you have those correct units as well. All right. I did want to just mention, in terms of scoring on the AP exam with significant figures, for the free response questions, anything where significant figures would be part of your answer, all right, there's a maximum 1-point deduction for that question. So if you make, in terms of significant figures, so if you make another sig fig error somewhere else in the problem, you won't have any further deductions to your grade. The other thing I wanted to point out is that they're a little bit more lenient on sig figs than I am in my first year courses. As long as the answer you record is within plus or minus 1 sig figs of how many you're supposed to have, there won't be a problem. If your answer is supposed to have 3 sig figs and you write down an answer with 2 sig figs, you're fine. If you write down an answer with 4 sig figs, you're fine. But if you write down an answer with 5 sig figs when you were supposed to have 3, you're going to hit that 1-point deduction. So you want to just keep track of that. When in doubt, go with 3 sig figs. I've heard that advice from a number of people, and it's not a bad move. Just so you don't get too hung up on this. You don't want to be obsessing about it. And finally, I do want to thank the Hack Scientific Foundation for making these podcasts possible.